Okay, lesson 3. Now we're getting into reflections. So again, looking back at this equation, so what we've done so far, we've done H and we've done K. Now we're going to be focusing on A and B. And this is why, like in your homework questions, we have lesson 3 and lesson 4 is like the same homework set, is because reflections are really just going to be talking about like making the A value negative or the B value negative. And then in the next lesson, we're going to make that like -2 or -4. So they're actually kind of the same thing, like reflections and transfer or stretches. So yeah, this will be a quick one, and then we'll do lesson 4. So okay. So first off, definition. So an invariant point are points that do not change after the transformation occurs. So I'll show you guys some examples of that here in a second. Reflections, you guys have been doing that for a long time in previous years, right? Where you have a shape and you reflect it over the x-axis or you reflect it over the y-axis. So that's what we're doing now, okay? So, okay, vertical reflections. So vertical reflections are up and down, right? And they're going to occur when, if you have some function, y is equal to f of x, if you stick a negative out front of the function itself. And this kind of makes sense, right? Well, here, I'll kind of show you what I mean here. Okay, so if we had this function, let's see if we can do, like, just as practice, see if we can sketch this thing kind of without graphing it here. So how would I figure out what the x-intercepts on this guy are? You could factor it, right? So let's factor this quick. So that would be the same thing as, all right, I'm looking for numbers that multiply at 25 and add to -10. Yeah, -5 twice. That's weird. What's my x-intercepts then? There's only one, right? So that means this thing actually just comes down and touches on 5. So if, here, I'm going to go up by 2s here. So if this was 2, 4, 6, 8, then this thing would come down and touch right there. And good enough for us now. Like you'd have to do a bit more work to figure out where it crosses through for the other ones, but I know this thing opens up because it's a happy face and then goes up like that. Okay, so now if we just took that same function, right? So f of x is this whole function. So if I say, okay, what is y of negative f of x? So that's like negative of that function. Anyone want to guess at what would happen there? It's going to flip right upside down, right? So this thing would look, so in the same point here, it's going to, and then it's going to flip down. And this makes sense, right? Because on this one, any number, if I put in, like I don't think these are the numbers, but let's say like that point right there, right? So when x is 2, y is some number. If I just put a negative out front, then it's going to be that same number, but negative. So then it's going to be flipped down there, right? So then that's just what's happening on every one of these points. What would my invariant point be here? So a point on the graph. Oh yeah, so yeah, I think so it's a point on the graph though, so it's going to be, yeah, 5, 0. So the invariant point here is going to be the point 5, 0. And this makes sense, right? Because what we're doing is we're making all of our y values negative, right? So I'm flipping all of those y values down to the bottom. Well, if I make 0 negative, then I'm still at 0, right? So that's why it's invariant. It's because it doesn't, when you do something to 0, when you make it negative, it doesn't do anything, right? So, okay. Yeah, so you guys can look through that if you want. Okay, so now horizontal reflections. Similar to the last one, right? So now instead of the negative being out front, the negative is actually attached to the x, right? It's like on the inside of the function. So really what would happen here is all of these x values, right? That x value and that x value would be replaced with a negative x. So it's like what's going to happen when we replace all of those x's with a negative x? How is that going to change the graph? And it's going to horizontally reflect. Okay, so if we just sketch that same one quickly again, so if it was there and just kind of went up, then this graph is going to reflect over the y-axis, right? So it's going to reflect horizontally. So that point that was over here at 5 now, if I was going up by 2s like I was before. Right, exactly. So now all your x values are going to turn out to be negative. And that makes sense, right? All of your x values are going to turn out to be negative. So any x value that you had will be the negative version of it. Okay? But it's going to reflect because let's say, you don't need to write this down, but like let's say I had like a point over here on some graph. So it was already, let's say it was at the point like -3. Then if I went -3, that would now be positive, right? So that would still reflect it over to that side. So it's always going to reflect it over the y-axis. Okay, so that's the idea there. Oh, sorry, and then you can sketch it. Okay, invariant points. Yeah, what would you?
Where it crosses the y-axis.
Yeah. So 0.25, right? And I can tell that from here. I know, even though we can't see it, this thing would have crossed, the y-axis up there somewhere if you carried it on, and that point would have stayed the same because if you go -0 for your x value, you're still at 0, right? So it's going to be an invariant point there. So that would be the point 0.25.
Will there ever be more than one invariant point?
Yeah.
Like,
We'll show you. Yeah, we're going to have well, yeah, I guess there couldn't be on that one because then it wouldn't be a function anymore, but we're going to get into that. Okay. Okay, I explained most of that. Okay, let's actually just try some here. So, given the graph of f of x, so this is quite often too, right? Like this is just the general graph of f of x. Like I don't know what that equation is. It's doing all kinds of weird things. It's just f of x, right? But this graph, they're saying that what we're going to do is we are going to go negative of that function, right? So we want to sketch this on the same grid. So first off, what is that negative doing? We get what? Yeah.
Flipping along the x-axis.
Yeah. We are flipping it in the x-axis. And I don't know if I brought that up yet. I kind of go over it a bit more after. But when we reflect things, it's kind of confusing sometimes. So it's a horizontal. Here, I'll write it down here too. So we have a vertical reflection. So often VR, and then it's going to be written as in the, which is a little confusing sometimes. So vertical reflection in the x-axis, which is confusing because you're thinking, no, I thought that we changed all the y values. What's this x-axis talk, right? But it means it's like reflecting over the x-axis. So when we say it's reflected in the y-axis, that's what we mean. Okay, and it's the same thing with horizontal. It would be a horizontal reflection in the y-axis, or about the y-axis sometimes too, yeah. Okay, so let's sketch it. So let's just start with this point. Where would that point be? That point, -4, -3. I can tell you guys are already doing it, so I'll just carry on too. So that point would now be here, right? So it's reflected over the x-axis there. This point here, it's the same thing. It's going to be up there. Let's do C. So this point right here, where is that going to be?
Wouldn't it be on the same place?
Right. That's an invariant point, right? And then your D value is now going to be flipped down to the bottom. So it's at 4 for Y value. So now it's down to -4. And then E is going to add -4. So it's going to be up to +4. And then we can kind of just connect the dots. There. Okay, so what's the domain and range of this graph? So we'll say the domain, and I'm going to use interval notation because I haven't used it for a while now. So interval notation, so that's the one with the brackets, right? It's going to be round bracket or square bracket? square bracket, right? Because it includes this point. So we're starting at that point and saying it's going to start at -4 and it's going to go to 5. And it also includes that point. The range, so it's going to go from, well, it'll start at -4 and it's going to go up to 4. Okay, write the mapping notation. Okay, so the mapping notation on this is just going to be the point x, y, so any point, is going to turn into, and then our x's didn't change at all, did they? Right, so I'm just going to write x again, they stay the same. And then what happens to our y values? They're all going to be the negative version of them. So it'll be negative whatever the y was. So there you go, that's our mapping notation. And invariant points are going to be the points. So yeah, when you were asking if there was 2, there will be 2 when we're dealing with things that are functions sometimes. So we're going to have the point 0, 1 and the point 0, 4. Oh, sorry, yeah, my bad. 1, 0 and 4, 0. Thank you. Okay, you know what? We're gonna do 3 and 4 as one video too, so we'll just keep going. Okay, so stretches now. I didn't have my little formula, but anyway, so now we're dealing with A and B, right? So it's just the other 2 variables there. So here, I'm gonna cut to the chase here. Vertical stretches, we're gonna have some value out front of the function, okay? So that value, like it was a -1 before, right? When we reflected it, that's all it was. But now we're gonna make it like 2 or 3 or that type of thing. And when it's out front, it means we're multiplying it. So we're gonna like multiply this thing by some value to make it bigger, like multiply to make it bigger. Or let's say if I multiplied A, or if A was like 1/3, it could be a fraction, right? And then I'm really, well, dividing it by 3 in that case. You're making it, you're squashing it. Okay, so you're either multiplying it or you're dividing it by that number to stretch it. So if we start off with the base, so function, the absolute value of x. So that's just our V shape. And then we made our A value, whoop, that's too thick. We made our A value 3. Then what we're saying here is that we have a vertical stretch, so often VS of 3. Okay, so what that means is, well, let's do the first point again. 0, 0. If I multiplied 0 by 3, still at 0, right? So that's still going to be a point on my new graph. But let's look at this point now. So the point when x was 1, y was 1, right? So now, so that point there, like if it would have been 1, and then I multiply it by 3, where is that point going? 3, right? 1 times 3. So that point's now going to be up there. And then the same on the other side. Right, because the absolute value on that side too of -1 is 1 times 3, going to be up at 3 again. So can you see what happened there? We ended up like squashing it.
So like when you said like you go 1 over and then odds up, could you just multiply the odds by 3 for where you're going with it?
On this one? Yep. Well, yeah, every one of those points is going to go up 3. So you wouldn't multiply, you'd add.
Just go up the same.
Yeah. Yeah. Okay. So now this one, so 2y is equal to absolute value of x. So again, I think right at the bat, I wouldn't leave it like that. I'd rewrite this as y is equal to 1/2 times the absolute value of x. And then I can see that that'd be just the same thing as dividing by 2, right? You're taking a half of the number. So if I look back at my original, again, it's going to start at the point 0, 0, because half times 0 is still 0. But now, let's say if I looked at that point, you know, it used to go through there, and I say, okay, what happens to this? So this used to be a 1. So that would now be down at a half, right? So that would actually be like right there, like at a half. And you could do that. It's a little awkward, though. I think what I'm going to do instead is I'm going to take the point that was at 2, so I knew it used to go through there. That would now be down at 1, right? And then that'd be the same on the other side. So we get a graph that's been squashed. Or, yeah, squashed down, yeah. Okay. So that's it. So things to remember, the A value only impacts the Y value, right? That's only going to affect things in the Y. Vertical stretches occur when we say like about the x-axis again. So even though it's like we're thinking, okay, it's changing the Y values, it's happening about the x-axis. So just make sure you get that one straight. And then x-intercepts won't be affected again, right? Because 0 times any of these numbers is still 0. So, okay, horizontal stretches. So now same thing. So our B value though is attached to the X. So we're going to replace the original function, absolute value of X, with 3X, right? You're putting 3 in place of what used to be X in the original. Okay, so here, let's just sketch this again quickly. Okay, so now these ones are a little bit different to think about. So again, it's still going to be at 0, right? Because 0 times 3 is still 0. But this point that was right here on the original, well, now I can see, well, these are always going to be the opposite of what you think they should be, just like last time. And you can think about it this way: if I wanted this thing to be 1, or like it was, then X in this case would have to be 1 over 3. Right? Is what would happen. Either way, if you don't remember it that way, what actually happens is always going to be the inverse of that number. So if it's 3 over 1, it'd be 1 over 3. If it was like 5 over 6, it would be 6 over 5. So it's actually always going to be the inverse is what actually happens on that one. This is the most tricky one to remember, right? That your X value with your stretches is always the opposite that way. It's always the inverse, okay? So in this case, if it's always the inverse, then we could say that we have a horizontal stretch of, and then I'd write out 1 over 3, just so I don't get confused. Okay, and then, so sorry, back to this now. This point that was here on the original function, I'm dealing with the X values now, right? So the X values, so I'm going to squash this thing in, right? So this point that had an X value of 1, what's my X value going to be now? 1 over 3, that would actually be there now, right? So instead of going like up and down, I'm going left and right with these ones, right? So my X values are what I'm looking at. So the X value was at 1, and now it's at 1 over 3. So it might be easier, again, to like look at, so in the original function, you know, the point was right there. So that was at 3, right? The X value is at 3. So I'm going to divide that by 3. I'm going to be down to 1. And then the same on the other side. So this graph actually turns into that. And sorry, I'll erase those so it doesn't look so confusing. Okay, so again, now we're looking at this one and we've got 1 over 2. So this thing would have a horizontal stretch of, what do you think? 2. So now I'm just multiplying all my values of X by 2. So again, this thing, so it's going to be at 0 again. There was a point at like, 1, 1. So now I'm thinking about the X's, right? So all my X's are being multiplied by 2. So now this point that was there, the X value should actually be over here. Right? The X value has been stretched by 2. So it's going to be 1 times 2. So now it's there. And then the same on the other side. Oop. Oh, man. I have a hard time drawing that way. Good enough. Okay, so B value impacts the X values only. Yeah, we'd say they occur about the Y-axis, and then Y-intercepts will not be affected. Okay, so mapping notation will be the same type of thing, right? So let's do some examples. Okay, so it says write the replacement for x and y and write the equation of the image of y is equal to f of x after each transformation. So after a horizontal stretch by a factor of 6, so let's write this down, horizontal stretch of 6, and that's really it. So our function is y is equal to, here I'll write just the ones we're dealing with now, would be a f of b times x. So horizontal stretch, am I dealing with a b or am I dealing with an a? B, right? So horizontal is the x, right? So it's a b value. Okay, so what would my b value be? 1 over 6, yeah, because it's going back in the equation, right? That's the only time that it's like flipped, it's like the wrong way, is when it's going into the equation. Mapping notation is the way it really is, and the equation is the backwards one, okay? So 1 over 6. So putting that in, that's just the same thing as y is equal to f of 1 over 6 x, which would be the same thing as f of x over 6. Either way. Okay, next one, a vertical stretch by a factor of 1 over 5 about the x-axis. So in that case, that's going to be our a value, right? So what will our a value be? 1 over 5. The y's are the easy ones, right? They're exactly like you would think. So the a value is 1 over 5. So that'd just be y is equal to 1 over 5 f of x.
Could it also be 5y equals f of x?
Yep, exactly. Yeah, and you have to be able to go back and forth. So yeah, let's write it that way too. So good. So that would also be true to say 5y is equal to f of x. You can see it in either of those forms, right? Okay, a reflection in the x-axis and a vertical stretch about the x-axis by a factor of 3. So let's write these down, especially when you start getting more than one. Let's write them down just so we can get them all. So it says a reflection in the x-axis and a vertical stretch. So I'll do vertical stretch first. So vertical stretch of 3. Okay. And then if it's a reflection, that's really just going to be like, you can almost think like this too, it's negative 3. If that makes sense. Or it has a vertical, or you could say, here, we'll do it this way too. We'll say a vertical reflection. In the x-axis, right? So you could write those two things, but really in the end there, what's happening? So y is equal to a f of bx. Okay, so if it's vertical, we're talking about the a value, right? So all we have to do here now is just say y is equal to, the vertical reflection just made it negative, and the stretch was 3, so I can just call that negative 3. Times f of x. Okay, horizontal stretch about the y-axis by a factor of a half, and a vertical stretch about the x-axis by a factor of a quarter. Okay, so horizontal stretch of a half, and a vertical stretch of a quarter. Okay, so it's y is equal to a f of bx. All right, so y is equal to, so what's our a value going to be? So vertical stretch of a quarter.
1 over 4.
Yeah, it'll still be a quarter. Yeah, so 1 over 4. F of, and then what's our b value going to be? 2, good. All right, so it was 1 over 2, so it's 2 over 1, or just 2. How does the graph of 5y compare with the graph of, 5y is equal to f of x compared to the graph of y is equal to f of x? This is actually, well, just what you were saying there, right? That your a value in this case. So if we divide both sides by 5, then we can say y is equal to 1 over 5 f of x. So that just means that there's been a vertical stretch of a fifth about the x-axis. Okay. Yeah, let's move on. Okay, so next one here, so graphing. So kind of like the other one we did in the last one. So consider the graph of y is equal to f of x. Draw the graph of y is equal to 2 f of x on the same grid. Okay, so first off, what are we looking at? So that 2 means that we have a, what kind of stretch? Vertical stretch. So we have a vertical stretch of 2. So do vertical stretches affect the y's or the x's? Right. Yeah, so the vertical stretches are happening to the y values, right? So all I got to do when I'm looking at this graph then is look at the y. So I'm going to look at this point and say, okay, the y value there was 4. So what's it going to be now? 8, right? 4 times 2 is 8. So that would be up there. All right, down here. So the y value on that guy was 0. So where's that going to be now? 0. All right, it's going to stay there. Next one, so this point here, the y value on that point was 2, so that's now going to be at 4. The next one, so that one, same as the other one, right? The y value was 0, so it's still 0. And then I think you're probably getting the image there. So this one that was at 4 is now at 8. And then connect the dots. There you go. Okay, so what is the domain and range of the image? So domain was, it started at -6, right? So square bracket, -6, and it goes till 6. Our range is what? So the range goes from, what's that? 0, yeah. 0 to 8 now, right? You know what? I didn't have this in here too, but let's actually look at the domain and range of the original, because I think it's going to be important here. So the original function was -6 to 6, right? That was the original, the blue one there. You see how that didn't change? Why didn't that change? We weren't affecting the x, right? Now the range of the original image, sorry, this isn't very neat, but the range of the original image was 0 to 4, right? Do you guys see what kind of happened there with the range too? The range values themselves, right? The beginning of the range value and the end of the range value. You can also just multiply that by 2, right, to get the new range. So if you're just given the range of the original, you can apply those rules too, because they're like for the one that applies to the x or the one that applies to the y, right? So you can just do that to the range itself too. Okay, so write the mapping rule. So the mapping rule for this guy would be x comma y. And then we've said quite a few times, right? We didn't do anything to the x's, so that's just x. And our y's, 2y. Everything is going to be 2 times all of our y values. Okay, invariant points would be the points that didn't move. So -2 comma 0 and 2 comma 0.
So is it always just going to be the x-intercept?
It will, right? Because it affects the y's. Well, those y's were 0, right? So if I multiply 0 by 2, it didn't do anything. Those are always going to be 0. Yeah. Okay, we're almost done, guys. Okay, so a polynomial function has the equation t of x is equal to that. Determine the zeros and the y-intercept if the following transformations are applied. Okay, so we got y is equal to -4 t of x. Okay, so what's happening here? We've got a vertical stretch of, the vertical stretch of what? Yeah, and you could say vertical stretch of 4, and then you could say a vertical reflection about the x-axis. But it's up to you. If you want to save time, I'm even okay if you say vertical stretch of -4, right? Because they're really the same thing. I'm just multiplying everything by -4, and that'll still reflect it, right? So either one. So first off, that's going to mean that there is no change to the zeros. So therefore, our zeros are still going to be at what they were to begin with, right? Our zeros were, well, the opposites of those signs, right? So that they would have been 4, -3, and -6. Here, I should state those as the zeros. Okay, what about the y-intercept? So if I want to figure out the y-intercept of this one, what can I do there? Yeah.
You should be able to multiply multiply all the constants together.
Right, yeah. We got to figure out what the y-intercept was in the original. So remember, if I want to find the y-intercept, then all I'm going to do is I'm going to throw zeros in for x, right? And then, so that's really going to end up being -4 times 3 times 6. So here, let's go define that. We'll say t of 0, instead of t of x, is equal to, and then I'll put zeros in for all of those. So we'll have 0 minus 4 times 0 plus 3 times 0 plus 6. So t of 0 is equal to, yeah, -72 as well, yeah. Okay, so what was -72? So now I know that means, according to our function here, right, that it's going to be, well, -4. So here, let's write this out. So the y-intercept is multiplied by -4. Okay, so the y-intercept would just be, yeah, so -4 times our number there, right, -72. So yeah, 288. Okay, you know what? Let you guys do this. Okay, we kind of jumped to the end there, so pause your screen if you're watching this as a recording and just kind of look over what we did.